I would like to welcome you in this new chapter where we're going to be learning about move semantics. And move semantics are a set of features that were introduced in C++ 11 to make it easy to use temporary variables in your C++ programs and avoid unnecessary copies. Let me give you a simple example. In the last few chapters, we designed our box container templated class, and it was used to do something like this. For example, we can create a box container for int, call it box1, and we can add data as we do here. The moment we do this, we will end up with something like this in memory. We will have a variable called box1. Its type is going to be box container, and we will be using a template instance for int for this class. So this box container is going to be storing integers. Once we set it up internally, it is going to be set up as a dynamic array. So this mItems pointer is really going to be pointing to a dynamic array somewhere in the memory of your computer. And we can go through this object and manage what is stored in this array here. For example, we can add stuff, we can remove stuff. We saw how all these things could work. But what we want to really see is how this thing behaves if we have temporary values involved. To try and understand that, we are going to create another box container object from the current box container that we have. So we will build box2 from box1. And from what we already know, this is going to call our copy constructor. So what this is really going to do, it is going to set up a new memory location with the size of this box object. And we are going to copy data from box1. This is what we are going to do. Let's try and visualize this. This is going to be using our copy constructor that is visualized here for ease of reference. And the copy constructor is really going to set up a new dynamic array, which is going to be managed by our mItems pointer. We are going to set up the same capacity as the source object. We are going to set up the same size as the source object. And we are going to loop around and copy data from our source object and store copies in our newly constructed box container object. Let's visualize this again. So we will have box1, which is on top here. It is going to have a pointer managing this dynamic array, which is ending in 111, and I mean its address here. We are going to set up a new box container object, which is going to be box2. And this is going to set up a dynamic array with the size of the source object. That's what we have here. But the moment we create our dynamic array with a new operator, it is not going to be initialized. It is going to be default initialized. That's why we have a bunch of zeros in here. But the moment we loop around and copy the data from source object, we are basically going to be taking whatever is in the first slot in the source object and storing that in the first slot for our destination object. And we are going to do the same thing for all the data we have in our source object, basically putting copies in our newly created box container object, which is managed by this mItems pointer inside our box2 object. This is how our copy construction is going to work. Now, what happens if we try to add up box1 and box3 and store the result of this in another box container that, for example, we call box4 here? That's what we're going to see. But before we look at this, let's look at our operator plus for box container and see how it works. It is going to create a local copy in our operator function. So here is our operator plus. It is going to take two box container objects and we are going to add them up. Inside the body of this operator, we are going to create a local copy, which is going to have the size of these two guys added up. And we are going to take this local object and add the data from the left object. And we are going to add the data from the right object. And what we will end up with is a box container that contains everything we had in left and everything we have in right. And we are going to return this by value to be used by whoever happened to call this operator here. So what we are going to end up in our setup we have in our code, this is going to create a copy which is going to be living somewhere in the memory of your computer. And this is going to be storing our box4, which is going to contain the data that we have both in box1 and box3 here. So we are going to have 1, 2, 3, 4, and 10, 20. And all these guys are going to be stored in our box4 object here. So this is going to be box4, and inside we will have 1, 2, 3, 4, and 10 and 20 as the data, because that's the data we had in both box1 and box3 here. But this is going to be a temporary memory location. Now, because we are doing a copy construction, the compiler is going to steal copy from the temporary object and store the data in box4, and hopefully you can see that this is really bad. But before we explore this further, let's visualize this. So we have box1 and box3, and we have the data n. We have 1, 2, 3, 4 in box1, and we have 10 and 20 in box3. We are going to add them up and create a temporary object, which is going to be box1 plus box3 here. It is going to contain the summation of what we had in box1 and box3, and we are going to have 1, 2, 3, 4, and 10 and 20 in here. This is going to be our temporary object, but we are going to copy construct from this temporary object. So what we will do is set up another box container object because we are using the copy constructor. These guys are going to be default initialized to 0 because of the new operator to set up our internal dynamic array. But after we have the dynamic array, we can copy the data from our source object, and we will end up with something like this. Now, watch the problem I want you to see here. The moment we have the data in box4, the temporary object is going to be destroyed because we don't need that anymore. So what is basically going to happen is that this guy is going to be thrown away, and we will end up with our box4 that we wanted in the first place. But notice the waste we just did. All this object here, the data that it is managing, it is going to be thrown away, and we really went through the trouble to set up this entire thing only to copy from it and throw it away. And this is a really big waste. We don't want to do something like this. That's why we have move semantics in C++. It is a bunch of features that really make up a mechanism we have to avoid throwing away those temporary objects that might contain the data that we actually need. And using move semantics, we can avoid unnecessary copies. So if we have our box container object, which is a temporary here, what we would really like to do is to not throw away this temporary object, but we can steal data from it. So for example, we can make our pointer here go and point to the temporary object internal dynamic array, and we can tell it mItems pointer to be a null pointer. We can tell it to reset itself to null pointer. So we can do something like this. And then the memory location that was managed by this temporary object is going to belong to us. When the temporary object dies, it is going to die alone. It is not going to go with the data that we need. The data is going to stay, and we will be pointing to this data here. This is the setup we want, and we can achieve this using move semantics. So by the time the temporary object dies, the data is going to be ours, and we will have a situation like this, and we will have avoided unnecessary copies in our C++ program, and this is really cool. Now, to be able to achieve this, you need to understand L values and R values, and we will be exploring these concepts starting in the next lecture. But for now, I wanted you to have an idea of what move semantics are and the main purpose. And we are going to start in the next lecture and learn about the basic tools we need to take advantage of this really important feature in C++. So we are going to head over in the next lecture and learn about L values and R values. Go ahead and finish up here and meet me there.